Okay, good morning, guys. So this week is also about hypothesis testing. So last week we have the what's that? I forgot his name. The level PS name, and you can do you can find a UMP test for the test. Look at this. And now we have another series called the Ruby series. And from this series, we can find UMP test for this one-sided test. And the key assumption is monotone likelihood ratio. So if the test is look at this, usually you have to check the monotone likelihood ratio first. And also the UMPU test. So next is another series, you have to check the actually this series can only hold when the densities look like the exponential family. And you have to measure the test. You have to find the contrast C1 and C2. To satisfy the condition is satisfy these two conditions. And also we learn the definition of a p-value. Okay. Okay. Any question about this? Okay. I'll do question 1 first. This is a homework question. And yesterday, Sen asked me this question, and I didn't solve this. Yeah, but I figured out a way to make it have a better form. Okay. So here you have two density. So when theta equal to 1, the density is look at this e to negative y. Okay, we say the value of x and x squared. And we can calculate its density. The first one is the density is say as x. And the second one, the density is look at this. Is this? Yes. Okay. And we want to control the UMP test. Okay. So this is a simple test. So that means we have to use a neighbor Pearson neighbor. Pearson. Okay. So theta equal to 1, theta equal to 2. The density is look at this. Okay. So by the neighbor Pearson neighbor, we know that the candidate of the UMP test have the following form. So the T may be depend on the constraint, the cut point C, 1 0, and 1 if the density of the 2. So say F. Let's say this one is F1, F2. Okay, F2 Y is greater than constant F1C. F2Y is smaller than constant F1C. Okay. So basically we want to find here what's this ratio. And this is look at this. So here's 2. E to y minus this. Okay. Okay. And the problem is not this function. Let's say it's g y is not a monotone function. So that would be much harder to find C. Okay. But if we analyze this function more, we will recognize this is the G is a convex function. So if G is a convex function, actually the G will look at this. So this is okay. The convex function and the local minima or the global minima is at 1. Okay. So this is G of y. So if this is a convex function, then we can have a couple C. Then the rejection region will be here and here. So in that case, the condition for the TC can be, look at this. So this can be C1, C2. So the T may be depend on C1 and C2, Y. And we will reject that if the Y is smaller than C1 or Y is greater than C2. And if Y in the between, we will not reject. And we want to find C1, C2 such like the C1, C2 such like this. The condition on the rule. So is theta equal to 1. It's alpha. So the spherical level is alpha. And also we have another condition. So you can see that in the function gy, the value of gcy and gct should be the same. So we need another condition. So we have 2 parameters and we have 2 conditions. So we may be able to solve that. Yeah, but I think it still be very hard to solve this question. So as long as you do this, it is very good. Yeah. So yeah. So sometimes after this is neighbor Pearson lemma, and the second step is we want to figure out what is the property of G. So if G is monotone, then that would be very easy. So we will reject if value too big. But here is not monotone, so the case become much more complex. Yeah. But see, this is still not be able to solve analytically. Yeah. And when we figure out G is monotone, is you just find the first derivative. And there's only one solution. And you can also see that so the G of needle is G y go to infinity is infinity, and y go to needle is also infinity. And we find the first order of derivative of G y will be like you can figure out that G1y is needle, I think. Yes. Okay. That is a derivative of Gy. So okay. Okay. Any questions so far? Yeah.
So you created this kind of indicator function of the rejection region, right?
Yes.
Okay, so that's like a helpful thing to do in this type of question, I guess.
Yeah. So usually we define a test as a rejection region. So on which way we will reject and which domain we fail to reject. Yeah. So just like the here. Let's look at here this.
Yeah. Okay, I see.
Yeah.
Thank you.
Yeah. No problem. I think in the exam, if you if you figure out the G is very dirty, then you can just leave as a look at this, and in general you can get the almost all the point. Yeah. Okay. So next is question 1. Okay. Okay. And now please do question 2. So this is monotone. First, you have to check this monotone Latin ratio, and I think this is old version. I delete this question. Uh, please try to find out the UMP test for this. Okay. So we have to use the Carney-Loomis theory. So you have to measure this monotone Latin ratio, and you have to figure out is it increasing or decreasing. That's important. Okay. And file the UMP test. Yeah. Uh, Level 3. Okay, let's go to question 2. Okay, so this is our function. So we have the density, look at this. Oops. This is a logistic density. Okay. 1 plus. Okay, it's not. Okay, the first part is want to figure check this morphonetic ratio. So let's say the theta 2 is greater than theta 1. And we want to figure out this. How many data do we have? Was it only one sample? So just like this. Okay. This is a monotone. Is it increasing or decreasing? Okay. Okay. So let's plug in this into the density. Well, we may have this. And also we may have the same thing on here with x theta 1 and another one in here. So we will we can cancel x. So it can be e to the e1 minus e2, theta 1 minus e2, and this. Okay. So this is a constant. And only this one is depend x. So we can only show whether this is monotone or not. So let's say this one is g of x. Okay. So check g of x. Okay. The g of x is equal to let's we want to figure out where this is. Okay. Let's find the first derivative of g of x. So you maybe look at this. The numerator, the denominator is this square, and we multiply another term. And find the derivative of numerator is e to x minus e1 minus this is the numerator, and derivative of denominator is e to the x minus theta 2. Okay. So it's equal to the denominator is the same, and we have the e to x minus theta 1 minus e to x minus theta 2. And this term can be cancelled. So we only have this. Okay. Okay. And we know that the exponential is a monotone function. So e exponential is a monotone function. And s minus theta 1 is the greater than s minus theta 2. Okay. Because theta 2 is greater than theta 1. Okay. So this is greater than this. Then that implies g upon x is positive. So g is monotone, is increasing, and that means the ratio is increasing. So okay. So this is a monotone ratio. And for another question B, we want to find a UMP test for the hypothesis testing. Look at this. Is which side? Smaller than greater. Okay. And this? Oh, just little. Okay. Okay. If the likelihood ratio is monotone, that means if x is increased, if the likelihood ratio is increasing, that means if the x is increasing, then we tend to choose, we tend to believe theta is large. How I say if x is large. Okay. So for this is we will reject if the theta is large. So we will reject if x is large. So if the likelihood ratio is decreasing, then you have to change the sign. So we will reject if x is small. So
Are the subscripts reverse? Is that the first one H naught or H1?
oh, the H, yeah, this H naught and this H1. Yeah.
Okay.
Yeah. Sorry. And so by the Conley Ruby theory, the candidate, the test will be look at this. So we will reject if the x is large, and we fail to reject if x is small. Yeah. So this is because the monotone likelihood ratio is increasing. So if this is decreasing, then you have to change the sign to like this. Okay. So it's very important to make sure you figure out it's increasing or decreasing. And also it's also depend on the test. Yeah. Yeah, this is increasing means if x is large, then this y is large. So we would prefer the theta is large. Yeah. Okay. So we have to check, we have to find see such lines this under the rule is alpha. Okay. Here we only have to consider theta equal to 0 because it is a monotonic ratio. Yeah. So this is equal to so integrated from c to infinity and e to the negative y e plus ey squared dy. Okay. And it should be equal to alpha. Yes, we are right. Yeah. Okay. So this is a CDF of y. Yeah. So alpha. So the C should be 1 minus alpha, the inverse of CDF. Okay. And this is a logistic distribution. And I forgot whether this is integrable or not. But the CDF is monotone, so you should be able to find the inverse. Yeah. Okay. So that is question 2. Any questions so far? We have 30 minutes. Okay, so if you don't have a question, now please do question 3. So question 6 is want to find U and PU. Okay. So the first step you have to do is you have to find a sufficient statistic U and make sure it is it have a density. Look at this. Okay. Okay. Hmm. Okay, let's go through question 3. Okay, so we have n data from this distribution and another n sample from this distribution. Okay, so this originally want to test this. Mu1 is not is equal to mu2. And this is equivalent to the test like this. Okay. Then we can do we can use the theory. Okay. Okay. So we want to find a sufficient statistic for this variable. Okay. And you can show that this is a x bar versus y bar is sufficient. Okay. And let's say this variable is z, and z is a normal distribution of the what's the variance is 1. Okay. That's 2 divided by n. Okay. So it's satisfied. That's the theory. Okay. Okay. So now we have to do is we want to find by the theory. The test should look at the UMP test, the UMPU test. UMPU test. It looks like we depend on two variables, C1 and C2. And we will reject if the Z, if Z is greater than C1 or Z is smaller than C2. Greater than C2, smaller than C1. Okay. Next. And we will fail to reject if this is in this interval. Okay. And it should satisfy. And it should satisfy the two conditions. The first one is the security level is alpha. So alpha is equal to under the list. Another one is the this multiplies z should be equal to alpha and z condition mu. Okay. Let's say this is 1 and this is 2. Okay. Usually you want to solve 2 first. The average of z condition this is 0. Okay. So we may have the C2z zero, and this is equal to the integrate from C2 to infinity z fzz dz plus the negativity to C1 dz. And we know that the z is symmetry, so this is equal to this term is the same minus C1 to infinity. Okay. So you have this term, these two terms are the same, So that will imply C1 equal to C2. Okay. Then we go back to equation 1. Okay. The equation 1 is the alpha equal to this. So because C1 equals to C2, so this should be like C equal to infinity fzz dz plus, okay, let's say 2 times this. Okay. Okay. And this is a normal distribution, so you can figure out what is the CDF. Okay. Then we can solve C. Okay. So C should be okay. The Z is normal linear sigma this. So alpha is equal to 2 times y minus, so this is okay. See, is that true? Yes. So we solve this, we can get the 1 minus alpha over 2 even should be this. So the C should be inverse of this, and it's not true. Okay. Okay. It's 2 over n or n over 2. Okay. So the probability of a standard normal is this. Okay. But what we have is we want to find the probability of this. Smaller c. This is a distribution of z. So it should be n over 2. Okay. Okay. Then so let's see. If C1 equal to C2, we reject for all x except C. Okay, that's a great question. So you say if C equal to C1, which has probability? Yes, that's true. So the Z is a continuous distribution. So we don't have to care about the equality. So if Z equal to C1 or C2, the probability is 0. So we don't have to care about, so usually this, maybe look at this, and we have to figure out what should we do if z equal to c1 or z equal to c2. But this, in this case, this is probably is 0, so we can get rid of this case. Okay. So we reject away always. We don't even need to look at this. We don't reject always. The sample is z. So if z is between c, so the final test is look at this. It's depend on z, and we will reject if the z is greater than this c, or z is smaller than this. Oh, okay, sorry. My fault. Sorry, my fault. This is negative c. Okay. Okay. So it should be negative c1. Okay. Yeah. Okay, so you look at this. Okay. Okay. Yeah, because I do this, so it should be negative here. Okay. Okay. Okay, so next is question 3. And the next question is about p-value. This just check the definition. Okay. We define the p-values like this. So the definition is this one. So if we have to check this. So we have a test statistic px. We want to check this smaller than alpha. And it should be under the, yes. Okay. Theta for all theta belong to 0. Okay. And we have the px, look at this. So next look at this. If px is smaller than alpha, so this is an event. That means the T alpha x, if alpha is greater than px, so I think I have to measure this first. So we have a rejection region, rejection rule this is equal to 1. And that thing we implies the T alpha plus x also equal to 1 when the alpha point is greater than alpha. So if we reject for small value alpha, then we will reject for any alpha is greater than this alpha. Okay. So if we will reject with the smaller significant level, if we reject for alpha, and we will also reject any significant level greater than alpha. So we have this property. So then the px smaller than alpha. This event means the T alpha. Alpha is below to this set. So how about I say this? Okay. Okay. So that means the alpha equal to 1. Okay, I see. Yes. Okay. So these three sets are the same. So the probability of this px smaller than alpha is equal to probability of the T alpha equal to 1. And this should be smaller than or equal to alpha because the T alpha is have say level level alpha test. Okay. Okay, I see. Oh yeah, that's question 4. Any questions? So for the hypothesis testing, we have the 3 theory. The first is lemma Pierce lemma, and this one is for the simple test. A Cardi-Ruby series for one-sided test. And the last one, we have another theory for UMPU test. We can do the two-sided test. Okay. Okay. So if you don't have any question, I think that's today's discussion.